I don't think I've ever had an audio guy that was that good at ending a song on time to be able to start. Give Seth a round of applause for that one there. Good tunes. Good tunes. Well, welcome. First session attends on the data center track. My name is Rick Claus, technical evangelist at Microsoft in Seattle. If I was a sailor, I would be a little bit upset because apparently you guys beat us by over a minute in the last race. Congratulations. You know, as a nautical theme, dolphins are good luck. As a sailor that's out on the ocean, if they have a dolphin going and jumping through that. I don't know if you guys know this or not, but the TechEd water bottles. Can you guys all pull out your TechEd water bottles for a minute, if you guys have them? Anybody have a TechEd water bottle on them? Come on. Nobody does? Okay, is there any water in it? Who has some water in a TechEd water bottle? This is a special thing that I'll share with you. I found this at a TechEd Australia. You leave the black tip on, it keeps it from spilling, which is good for me. But the other thing which is kind of cool is, it also doubles as a dolphin call. If you tip it up sideways, this way, so at 9:10, when the next race starts, I expect you guys all to pull out your water bottles and give New Zealand some more luck to continue to win. Good on you. Good stuff. But we're here to talk about server. We're here to talk about System Center. We're here to talk about a whole raft of different changes that are going on. I'm honored to be able to kick this one off. I'm a very passionate individual around server, around storage, around virtualization. This is an introductory session to talk about what the whole plethora of changes are that came about with Server 2012 R2 and with System Center, mostly with servers, what I'm going to be focusing on. This will also point you off to a bunch of different sessions later today and tomorrow. We'll be able to go into very much more depth than I'm able to go through in just these short 60 minutes that we happen to have. And I've got a bunch of demos to show up for you as well, but I'm going to try to go the non-traditional route for demos. I'm trying to find some stuff that you can use right now today inside your environment. You don't have to worry about doing any massive infrastructure changes. This is stuff that you can do in your lab environment, stuff you can do in production, and potentially may not get as much airplay as you would get in some of the other sessions when you're talking about virtualization or when you're talking about storage. So we'll see how we can mix it up a little bit and have a little bit of fun as we're here today. But we start off a little bit first about this concept of cloud and where cloud vision has been. You guys saw a bunch of this with Scott Gu yesterday with regards to Azure, working in the cloud, and that sort of stuff. But the idea behind a cloud OS vision is not just a marketing slide that someone came up with to be able to try to explain what we're doing with this release of Windows Server and Server 2012 R2. But it actually is a bit more than just that. And I was watching the keynote, actually there was the plenary in TechEd Australia, and also chatting with a friend of mine, Jeff Woolsey, at TechEd North America and back at Corp, about how he tries to explain this concept of Cloud OS and to make it real for people. And you guys have probably seen this before, where you break the cloud up into 3 different pieces, and you have the private cloud environment where we happen to have System Center 2012, 2012 R2, and also Windows Server 2012 and 2012 R2 down in one core. That's basically your on-premise stuff. And then up in the public side of things, you have Azure, you have Azure Virtual Machines, you got software as a service, you have infrastructure as a service that you can extend off to. And then down below in the other corner, you have System Center and Windows Server, but at this time, it's at the service providers. And Jeff actually did a really cool thing with this one. He's like, you know what, you can kind of think about this in 3 different ways besides just where stuff is located. Think of your private cloud as the area where you want the most ultimate and total control of everything. So think of control when you think of the private cloud, because it's all on-prem, it's inside your brick and mortar, it's inside your cool data center. You manage it, you work with it, and everything else. Think of the public cloud as scale. You can scale out to that area if you need to with some new technologies that we have built into 2012 R2 to be able to basically extend your capabilities, both on the compute side, on the storage side, connected with our networking side as well, to be able to work up inside the public side of things. And then finally, think of the service provider is when you're looking to try to maintain customization, if you will. Being able to take your data and keep it within the bounds of New Zealand, if you want to, as an example. Different hosting providers running System Center and also Server 2012 are able to basically offer you up infrastructure as a services to scale out, and also, more importantly, to be able to customize and to keep control of your data within the boundaries of your environment. It's kind of a neat way to think about all three of those. We've taken all the learnings that we've learned over the last 12 years and more running massive data centers on the public side in Azure, and also on our other software as a service solutions like Hotmail and Xbox Live and that sort of stuff. And we basically brought them into the Server 2012 R2 offering that we have right now, and System Center 2012 R2 offering. We're talking about automation, we're talking about storage, we're talking about compute power, we're talking about networking, how they all fit together. We've brought them in to what we're offering right now on Server 2012 and 2012 R2. Interesting way to think about it. Now, because you've got all these three different pieces that all are made by a company like Microsoft, as an example, you're able to have a consistent experience and a consistent platform across all of those. You can make a VM that's running on your local machine down here in your own private environment. You can upload that into the gallery up in Windows Azure and be able to spin it up in Azure if you wanted to. You can take your machine that's down your local site and you can make a Hyper-V replica to one of your service providers for disaster recovery in case a natural disaster happens to come along. You can go ahead and when you're developing any of your applications in-house or working with your dev teams, the same tools they're used to using to develop in-house applications can be used to develop applications as service providers and also up in the public cloud. Doesn't matter where those things happen to sit, provided they obviously code to the appropriate area. It's able to go off and to use a consistent, familiar experience. Familiar experience means ease of migration, ease of transition, and also integration into these different services. Same thing goes for management. I can go in and add in an infrastructure as a service machine into my server manager console if I wanted to, and be able to manage it just exactly as if it was on-prem. I can hit it with remote PowerShell if I wanted to. I can do the exact same thing if it's at a hosting provider. I can also go in and simply manage my systems with System Center and simply connect up my systems up to Windows Azure if I wanted to be able to get operations manager details or orchestrator runbooks going off and firing off different scalability runbooks up to the public cloud. It all just works with all the learnings that we've had. Data access in the cloud for where it happens to sit. Obviously, SQL happens to be present in all of those different areas, as well as up in the public cloud as well. And then finally, identity for a consistent platform, looking at Active Directory up in the cloud, both also on-prem and at providers, and finally, virtualization. Now, for a brief little history lesson, if you will, on Server 2012 and 2012 R2, it's kind of funny because how many people here have already gone off and started to deploy Server 2012? Previous version? A good chunk of everybody has already gone off and deployed it. Very good to know. You're already a step ahead. You're already great. How many people here are still on primarily for their server machines, desktops, server machines, sorry, Active Directory, file servers? How many of them are still running 2008 R2? 2000, again, almost the same number. So you've obviously experienced the fact that you can integrate and bring 2012 technologies into 2008 R2 environment. Fantastic. I'm going to actually be hosting 2 different sessions tomorrow specifically on how to get your older workloads, your older environment. It's kind of hard to think that 2008 R2 is old now. And then basically move and migrate it up to the 2012 environment. You'll see that 2012 is kind of your jumping block to get you off and into the 2012 R2 wave. And it's generally the way you want to be for being able to insert different functionalities into your environments without having to do a massive greenfield deployment of 2012 R2. So I'm here to talk about 2012 R2, but first I have to talk a little bit about a background of 2012 for what's there. Because there's a lot of stuff you guys might have missed, potentially, we're not aware of. I mean, this new release cadence is something that we've talked about a lot. It's speeding up. It used to be you could pick a consistent level of a server platform, and that would be your standardized platform that you'd be using for the next 3 years until your hardware needs to be refreshed. If you're doing that, you're missing out on the innovations that we're bringing in on a faster cadence. We've publicly stated we are speeding up our cadence. We haven't said how fast just yet, but do you know what the release cycle is for new features in Azure on the public cloud? Anybody? 60 days, 2 months, a month, 4 months. They come out like this. That would drive me absolutely bonkers if I was a server admin, having a new version of server functionality coming out every 60 days, 90 days. But it's the reality of what's coming. Things are speeding up. Going to the 2012 level and beyond is going to allow you to get in and take advantage of these new innovations in those areas you need to at a much faster pace. So from a 2012 perspective, in case you missed it, 2012 from a Hyper-V perspective, from a simple scale and scale-up workload support, massive amounts of changes, 5x times improvement as far as the number of logical processor support, 4 times improvement the amount of host memory that is now supported, 16 times improvement for the amount of virtual machine memory that's possible inside of a virtual guest that's out there. Massive, massive scalability changes. The buzzwords that people were using were basically, you know what, there's no longer an unvirtualizable workload out there because of the sheer limits that we now have on Hyper-V. We're able to get over 1 million IOPS, 1 million IOPS out of a single VM, talking to fiber channel SAN in the back end to be able to get that kind of a throughput. That wasn't even heard of back, yet alone a year and a half ago to a year ago. So massive amounts of performance improvements. In 2008, to R2 was only 250,000 IOPS. Now we're over 1 million. Where it happens to sit. Essentially, we've got the throughput and the power to get through to your disks to be able to access the processing at disk and nearline speeds. The performance scales linearly with the number of virtual processors that are inside that machine as well. Now, from a performance perspective on storage, well, we did live storage migration with something that was available. We also have a new VHDX file format that we've made available for everyone to use and to license and to make available. This new VHDX file format now takes the 2 terabyte limit, updates it to 64 terabytes per disk. 2012 R2 actually brings up the ability to get that terabyte limit for your iSCSI targets as well, up to that same level. I have a bad luck of having my PowerPoint kick out here while I'm doing it. Sorry, my demo machine to lock on me, so I just got to keep that guy running in live for my demos that's coming up here. We have virtual disk merge is possible, live new parent that can switch in. You got virtual fiber channel that came out, as well as automatic trimming and unmapping of space to reclaim space that's no longer required on the VM down to individual SAN. The big thing that I found that was really rocking with 2012 was the support for SMB3. Phenomenal capabilities on SMB3 side of things, where you can basically have your workload, like SQL or virtualization, instead of having stuff stored and locked away inside of a SAN environment with a LUN and a fiber channel SAN, you can now simply have that deposited on top of a special scale-out file server solution with SMB3 set up for an application share. And then you now have multipath to that guy, multiple sessions to that guy. You can even hand off, in case there is a back-end server failure of the storage, those open handles to the other nodes, and the VM doesn't even know this is going on. It's insane. SMB3 is like the fire-breathing dragon feature of Server 2012 that really just makes it light up for what you can do with it. Networking-wise, we enabled network virtualization over a year and a half ago. The ability to have our open extensible switch being supported by 30-odd vendors or so to be able to extend upon it. Nexus 1000 is a very popular one, and more. Offload, hardware offload for your network capacity on your servers. Fantastic from a performance perspective, with 10 gig Ethernet becoming more available. Mobility-wise, obviously you can move machines anywhere you need to move them, when you need to move them, from a single machine to a clustered system, from a clustered system back out to a single machine, between clustered systems, all without any packets or downtime. You can migrate your storage back and forth. You even have the ability, as I mentioned, to do shared nothing live migration, where there is literally nothing between those two systems except domain membership and a network cable between those two. And it simply moves the data across without having to rely on clusters. But then people were concerned a little bit about the scalability aspect of that and how many can you move at once, because the default is it stops at 2. You can actually open up to more. And so they actually made this quick little video just to show you, because I don't have access to the hardware to show you this particular part. What you see going on behind me is actually a PowerShell script that is set up to move 40 VMs, 2 gigs apiece, doing workload work on those systems between different hosts that are up and running. And if I talk long enough and extend this out, maybe take a drink of water, you'll see in the background that basically it's consuming all available bandwidth between those different systems. It's on 10 gig interfaces, obviously, for this to work. He's going over 19 gigabits or 18 gigabits per second for transfers. And you see those machines slowly start to disappear, and basically all 40 machines are migrated in around 2 minutes. And they're basically done. Phenomenal. So how about 2012 R2? That's what you're here to learn about. That's what you're here to see what's new and what's there as one of the many, many things that we happen to have going. In case you don't know, GA is around the corner in October. We just made available yesterday the ability to download it off of TechNet and MSDN if you want to go off and to update your lab environment and try it out. Obviously, you must have a proper license to be able to use it inside a production environment. A TechNet license and an MSDN license does not count as a production license to use it in production. But Server 2012 R2, we've been doing stuff since last TechEd North America around sharing information about it and making it available to you in what's known as the preview. How many people here have played around with the preview of 2012 R2 already? Not too bad, a good chunk of you. Get used to holding up your hands. At the end, I actually have a little bit of a prize for some Q&A and also for some, shall we say, trivia that I'll be asking at the end. If you pay attention, you can possibly win one of those lovely Nokia 520s when we come up at the end. With 2012 R2, one of the things that I did after TechEd North America is I sat down with a gentleman from HOL Systems. He runs the back-end infrastructure that does hands-on labs and also does TechNet V-Labs and vCenter Labs. And we did a 2-day immersive online jumpstart. I'm willing to bet probably almost none of you came to it because it was in PDT time zone, which meant that you would have had to have been up at around 2 a.m. to watch it. So for your benefit, I thought that I would go ahead and just include it right here for you now. This is all content on 2012 R2 and what's new. And basically, it is 2 full days of training. It's available online at microsoftvirtualacademy.com if you decide to go off and try it out. It's all free video snippets and training assessment questions at the end that talk about all these different functionalities and features. You'll be seeing a smattering of these in more detail here at TechEd New Zealand over the next 2 days, 3 days. And I love how the architecture animations can go so fast. I basically managed to get this down to about 2.5 minutes of accelerated play for where this happens to sit. There's absolutely no way I can cover 2 full days of content in less than 60 minutes. Basically, I got 45 minutes left. So I'm going to show you a couple of highlights of things that I found very impactful, something you can use right now, and some cool stuff. Following this session, as an example, over in New Zealand 1 is going to be Ben Armstrong talking about the changes in Hyper-V and the stuff you can do with virtualization and implementation of virtualization. Very, very cool session coming up. I've got a session on storage. Jeff Alexander has a session on storage at the end of the day as well, because storage is so important with what we've changed and what we've done in Server 2012. So instead of watching all this, the way we can break down and think about Server 2012 and what it brings to you, and System Center 2012 as well, is really in these 7 categories that are here. Capabilities, we call them at Microsoft. And I'm actually only going to have time to dive into 3 of those capabilities, the 3 big ones at the top: storage, networking, and virtualization. And I'm going to show you a couple of things in there. Inside the bottom of them, server management and automation, through PowerShell, through Server Manager, through open standards with OMI, web app platform with some of the developer side of things, access and information protection. There's some great sessions coming out this next couple of days on workplace join, on work folders, and what they can mean to you on the client side, and also VDI as well. So great stuff there. I'm only going to be spending time on 3 of these things in this particular session. And don't be shy, you can ask questions too. You can say hello, whatever. Hello, thank you. Someone's there. So, a data center without boundaries. What are some of the things we've done? Again, the ability to look at some of these sessions and some of these topics from the optic of large environments. If you're an IT professional, if you're a system administrator, if you manage your environment inside your environment right now, you provide services to your customers who are your internal clients, your users that are in there. You can think of yourself as a mini SI, a mini service provider, or systems integrator, providing services to your business units and services to your customers and to your users. A lot of these things you'll see look like they're massive, big-scale things that don't apply to you, but just step back for a moment and think of yourself as that SI, as that system integrator providing services to your customers. One example, one small example, is something as simple as virtual machine activation. I'm sure you guys love activating virtual machines, right? Cricket sounds. Well, virtual machine activation is a really cool feature. It gets kind of buried in there. If you have Windows Server 2012 R2 Data Center Edition, and you activate it with your license on that particular machine, all the guest OSs that are running on server are able to go in and to have a special local key used instead that simply checks and says, hey, is that local system, is that local data center server installed? Is that guy there actually activated? If he is, I'll go ahead and activate against him, as opposed to having to go out and punch a hole to go and talk to the internet or talk to your KMS server. Significantly easier, especially if you're in a very large hosting environment with thousands of customers that have no relationship to each other, and you got to somehow manage their KMS activations and that sort of stuff. This one little tiny thing. It applies both directly to you inside your organization and also to very large service providers as well that's out there. Enterprise class virtualization, robust open source support, best in class performance for all those different workloads that happen to be out there. So for our first category, first capability from a virtualization perspective, again, Ben Armstrong's got at least 2 or 3 sessions here at TechEd. I haven't seen all of them. I saw the ones for today. There's 2 today, at least, on virtualization, talking about the high-end virtualization platform that we happen to have. So you basically told us, hey, you need to go off and reduce the cost and complexity of how virtualization works and also eliminate downtime. And so with 2012 R2, we have one thing that's actually very cool. He'll be showing us later on. It's talking about cross-version live migration. If you've already started to work with 2012 and you've already got virtual machine guests on 2012, you can live migrate them over to a 2012 R2 system. And then it's now a 2012 R2 capable guest. Great. I'll be showing you a little bit later on the online VHDX resize capability. So you don't even have to shut machines down to be able to reclaim and allocate more virtual space on those disks that you made available to them. Provided there's underlying support for space, you can simply resize on the fly, and then the disk can go ahead and reclaim that space and use it for its own use. You told us that you needed to have some kind of easy way of deployment and also to support different life cycles and workloads. And so basically this automatic activation piece that I mentioned is there. Another neat thing that also comes up quite a lot is exporting a machine to be able to use it someplace else, give it to a service provider. Now picture this. You have a problem with a particular machine, it's acting up. You have issues with it, but it's still providing services. You can't take it down to troubleshoot it. You can do a live export of that machine, bring it up inside an isolated environment, and troubleshoot it in that isolated environment. Figure out what's wrong, and then go back and fix it without ever having to take the main one down. You said that we needed to have some better flexibility for virtualization platform. Well, we have the ability to go through from a migration perspective and not only simply go through and do a live migration between the 2 different systems, we also now can go ahead and compress the data that gets moved across to speed things up. We even have the ability to go and offload that data across the RDMA-capable network cards. Linux support. We are actually one of the largest contributors to the Linux kernel over the last little while with our enlightenments, with our additions, if you will, for Hyper-V to make it work inside the Linux kernel better, to support a wider variety of Linux guests and Linux VMs. They also now have the ability to support some of the new functionality like dynamic memory, like the resizing of the disks, like backups and snapshots now as well, which were previously some big sore points which didn't work on the other systems. So let's talk about live migration. Live migration has been available and inside the box for a while now. People are getting used to it. They like it. They understand how it works. But we have some new hardware capabilities that are there. We need to be able to increase the scale, the speed, and the performance for how live migration works. And so we now have the ability, when you do a live migration, the option of choosing, hey, do you want to live migrate this standard? Do you want to live migrate this with compression, which is the default? Or do you want to live migrate this with hardware offload if your NICs can support it? So people ask me, well, when should I choose this? Well, live migration with compression is the default, and that one there will put a bit of a CPU overhead on both the sending and the receiving side, but it's not that much. If you have the resources for it, you should be fine. And it will give you probably on the tune of around 2 times performance and speed increase, being able to migrate this. Ben's got some great demos to show you in this one here. I'm not going to steal his thunder, so he's got some good stuff. The other one you can do is if you have hardware-capable NICs, so basically 10 gig E and above, InfiniBand, Mellanox, that sort of stuff. If you're up in a higher-end network fabric between your different hosts, you can choose to do an RDMA offload. And so generally speaking, if you've got greater than 10 gigabit or 10 gigabit and greater network connectivity between your hosts, live migration compression is going to give you, less than. Live migration compression is going to give you your best bang for the buck. If you have greater than 10 gigabit connectivity between your hosts, being able to do a migration, RDMA offload is going to be your best bet, where you can get upwards of, based on your network, 56 gigabits per second between those different systems to migrate those systems. It supports ROCE, iWarp, InfiniBand, RDMA solutions, and others. Just make sure that you obviously have the appropriate networking switches and cards inside your hosts. Who here remembers having to move dip switches on ISA cards to choose the right IRQ? When's the last time you actually did that? Honestly. Like 10 years ago? 2 years ago. Wow. That's a prize for you, sir. Sorry, it's not the 520 though, but it's a prize for you. Yeah, virtualization. You open up a virtual machine, you take a look at Device Manager. Did you ever drill down inside of it? We emulate hardware that you haven't been able to buy in the last 5 years to 10 years or more. Like, when's the last time you actually saw a working floppy drive? You know, last week? Same gentleman up there. You're stealing all of my jokes, sir. We have this new thing with 2012 R2 called Gen 2 VMs. Gen 2 VMs are supported on 64-bit operating systems. 2012, Windows 8, 2012 R2, Windows 8.1 are possible guests. And the Gen 2 VM basically now supports the ability to do a synthetic NIC Pixie boot. To be able to go off and do OS installs, as opposed to having to add that gosh-awful legacy network adapter to be able to do a Pixie boot. We have the ability to go in to hot add and remove CD-ROM drives and DVD drives, the ability to boot from iSCSI targets. Even better, the ability to boot with UEFI firmware for a secure boot solution for virtual machine guests if your OS supports it. All that is supported in a Gen 2 VM. All you have to do is when you say new virtual machine, choose Generation 2. It's a stunning demo I'll show you in about 10 seconds. Online VHDX resize, the ability to go through and basically take an online VHDX file that's on a system and currently booted and working and operational. Go ahead and to expand that at the hypervisor level to say you now have more space. Once it's visible inside the guest, automatically you can just go in and say extend volume to take up the full space. If you want to, you can then go ahead and retract it and basically shrink it on the system, and then go ahead and shrink it back again. So while I wake my machine up, because once again it went to sleep, I was trying to find a live stream of the races to put on my secondary screen, but I couldn't find one, so I apologize. YouTube. I went to YouTube, it said it was geo-blocked. I couldn't get access to it. It was crazy. Welcome to New Zealand. Nice. Okay, got that. Switch over to here and take a look at this. There we go. Okay, so this is a Hyper-V box that I have back in my lab in Redmond. And I've got a Gen 1 and a Gen 2 machine. My Gen 1 machine right here is server 2012 R2. It's running. It looks normal as you would expect to see. And here is my Gen 2 machine on the same side. Going to go in here and just quickly say by type. There we go. They look pretty well the same on both sides from a device manager perspective to be able to see the different pieces that are inside the system. As you can see here, one thing that's missing, as I mentioned here on the Gen 1 machine, come on, here's my zoom. On the Gen 1 machine is, wow, that's latency going on. Well, Gen 1 machine, basically you can see here you've got your floppy disks, floppy drive controllers. Along those lines, you also have your COM ports, your serial ports, your LPT ports, that sort of stuff. Gen 2 machine over here on this side doesn't have a floppy drive, doesn't have those legacy serial ports and parallel ports and that sort of stuff. It just simply has information. If you even go through and look at this way, to say by connection on both of them, if I expand the ACPI architecture for 64-bit systems, you'll notice that there is a PCI bus, and then if I scan down the PCI bus, there is a PCI to ISA bridge inside the legacy VM, Gen 1. Over here, you basically have ACPI module, and then you've got the Hyper-V VM bus, and then nothing. It's just there. They perform a percentage faster. They boot a percentage faster. They run a percentage faster than the legacy stuff because you don't have to do any emulation. Ben will give you the exact details and numbers on that sort of stuff, but how easy is it to make one of these guys? Well, it's pretty simple, actually. If I get the right window going here. New virtual machine. You guys have seen this wizard many times, I'm assuming. It asks me at this point right here. There's my zoom. Wow, that was slow. Gen 1 and now Gen 2. It has to be Server 2012, 64-bit version, or Windows 8 64-bit version to be able to support it. And before anyone asks, you can't convert a Gen 1 into a Gen 2. It's simply net new creation that's there. And obviously, you can't migrate a Gen 2 down to somebody else. It's got to be running on Server 2012 R2. I'm not going to bother finishing that wizard because I'm sure you guys have seen the creation of a virtual machine before. But that's as simple as it is to be able to make a Gen 1 or a Gen 2. Otherwise, it behaves exactly the same as what you would expect a virtual machine to run on Server 2012 and Server 2012 R2, sorry. Now, how about that online resize? Well, let me show you that. This guy right here. Okay. So my online resize, you can see here on Disk Manager that I've got one disk at the bottom here that's 50 gigs in size. Here's a trick you need to know. For online resize, it's going to have to be a SCSI attached virtual disk inside my virtual machine settings. I then also have to have it formatted with a known file system. It can't leave it as just raw, unknown, because it doesn't know if it can shrink it or not, because it doesn't know where the data is. So I've already gone ahead and formatted this partition, and I happen to have given it a drive letter, and I've got 50 gigs in size for this particular one over here. If I go to my hypervisor and take a look at this guy, settings-wise, you can see here that this particular disk is the one I'm looking at. I hit Edit, launch the wizard, and I have a couple of options. I can either go ahead and compact it. Wow, zoom it slow. I can either compact it if I wanted to, or I can expand upon it. So I'm going to go ahead and say expand. And I'm going to say, let's make that 200 gigabytes in size. Now, in this particular demo, I'm going ahead and I'm using a dynamically expanding VHDX file on the host, so on the hypervisor. So it's not actually going to physically occupy more space. If it was a fixed disk in size, I could go ahead and basically expand. The possibility of fragmentation that could go on. But in this case, it's simply me changing some parameters within the VM or VHDX that says it's actually 200 gigabytes in size. I hit OK, finish, and then OK. And now if I go back into this guy over here and I do a rescan, I can now see that I have an extra 150 gigabytes in size. Look, that zoom's going to work better. Basically 150 gigabytes in size of more space available inside that disk. If I want to go ahead and consume that space, simply go into the partition that's the volume that's before it, say extend the volume, and I can now go ahead and through this wizard be able to make it the full size that I want to expand it by. So in this case, I could expand it by 150 gig to have more space to it. When I want to go ahead and basically reclaim that space because it's no longer required, I'm constrained for resources on the Hyper-V box. I need to get some of that space back, and there's space available inside that volume that I can reclaim. I basically would go through and shrink that partition down again. And this time when I go in and edit those settings for Scale-Up File Server 1, disk number 4, I simply go in here, and then choose to shrink it. Notice it's not compact. The difference is compacting simply is the file itself. Shrinking is actually reduce the capacity of the disk. If there is available space to shrink it, I can. In this case, because there is no data on that particular drive, it's only a sample data that I've got on there, I can shrink it down to 20 gigabytes in size. It warns me that, hey, that previous formatted partition is stated that it's 50 gigs in size, so you can't actually go down below the 50 gig limit to protect the data. So I'm going to say, okay, you know what? I'll shrink it down to 51 instead. Hit next, hit finish, and the disk shrinks. Back here on Scale Out File Server with a quick refresh, I can see that magical space disappears. Not bad, eh? Nice golf clap, anything? You guys are awake? Gen 1, Gen 2 VMs, the ability to go through and basically eliminate the redundant stuff you don't need to have inside your systems if you're running Windows-based operating systems at this point in time, and the ability to go through and to reclaim disk space and also get access to disk space back and provide more disk space to your Hyper-V guests on the system on the fly if you need to. Very simple stuff, but still very powerful stuff you can go ahead and start to use inside your environment. I got so many buttons to use up here. They actually have a shifting lever that I can flick back and forth for my transitions, but they've disabled it, so I have to use a button instead, unfortunately. So what else do we have? What other stuff do we have going on? Well, some other things we've done is really some big investments on the storage side. I'm a big storage nut, and so I'll be talking a lot about storage in my upcoming session just before lunch, in case you're interested, over in New Zealand 3 or 4, I think. But we're going to go through and talk about some storage changes, also some networking changes, and also some resiliency or redundancy changes as well that we've brought inside this thing. How many people here have SANs in their environment right now? Almost all of you have SANs. How many here have had a SAN that they've outgrown and had to buy another SAN to be able to support it? Isn't that fun? Having 2 SANs, and then 3 SANs, and then 4 SANs, and having to manage them differently and separately from each other, that sort of fun stuff like that. Well, storage is something that we've taken a big focus on 2012, and we've continued that focus in 2012 R2. And we're trying to simplify things. Again, do you know how many SANs there are in Azure? 1? A million? None? The answer is none. It's too cost prohibitive. Too crazy manual that you have to go off and manage these sort of things. They use direct attached storage and abstracted storage. It's way more cost effective to be able to do what they need to do in the cloud. Same thing goes for Google. Same thing goes for Amazon. You just don't use SANs in the cloud environment. It just doesn't make sense. It doesn't make economic sense. So I thought I'd demystify some storage stuff for you and talk to you a little bit about storage spaces and how storage spaces works in 2012. So your SAN environment, what your storage appliance basically, doesn't matter the vendor. All the vendors basically work the exact same way, including us. The idea is that in a storage appliance, what do you actually have? You've got processors, x86 and x64 processors that are running a custom operating system that are your controllers. You've got memory available, like you would have RAM for being able to cache and be able to run that operating system on your controller. You can also have network adapters that basically expose services to your clients, your servers, that you then go in and attach up to and attach to LUNs, that sort of stuff. And then you have, obviously, your HBAs to go and talk to your back-end storage. I mean, it's not rocket science. It's pretty simple. Processors running an operating system that are going off and using memory for cache and also for the operating system that use network adapters to present services to your clients, your servers, and also are using HBAs to be able to go off and talk to the disk in the back end. So really, you can kind of abstract it and simplify it even more by saying, you know what, you got a back end and a front end to a controller that's on a SAN. On the back end, you've got multiple different ways to physically attach up to those drives. You've got the ability to pool disks together. You've got the ability to present LUNs. You've got the ability to do different types of protection with parity, with mirror, with RAID, and that sort of stuff. And then you're attached up to a SAS controller or SAS cards in the back to be able to get access to all those racks and racks and racks of drives. On the front end, you've got the interfaces that go off and present different solutions that your customers attach up to, like iSCSI, like fiber channel targets, like fiber channel over Ethernet, NFS, or even SMB to be able to present stuff out to. And then if you need to, you can get a second or third or fourth or fifth controller to get a level of high availability of those individual services talking to those same drives in the back end. And then finally, you've got your clients, your servers, that go in with HBAs if they need to, or through iSCSI targets if they need to go off and talk and consume those resources on the back end. The difference is that every single manufacturer has different ways of presenting it, different ways of managing it, and different ways of being able to go off and control it. And each one has their own benefits and challenges, and they provide value add to how you do it. In Server 2012, if you didn't blink, we used the same architecture to be able to approve it. They flip back and forth between these two. Except the difference is that we're using 2012 spaces to be able to go off and to present the abstraction and talk to our shared disk that are in the back end. We use enterprise-grade commodity hardware in the back end to be able to go off and have access to shared SAS disk, SAS controllers, whatever kind of controllers you want. Our front end is our Windows Server 2012 file server. That can either be a file server, can be a scale-out file server, which is obviously the better way to go, that then is being able to be clusters built in. And you have basically 2 or more for a scale-out file server solution. And then we're using standard Ethernet connectivity for our clients, 1 gig, 10 gig, 40 gig, 56 gig RDMA, whatever kind of networking infrastructure you want on the front end to present those workloads to your clients. Now, when you tie this together, it's kind of given the ability to do some really neat design changes. So we actually went to our ODMs, original design manufacturers, and said, hey, we've got this great concept of being able to present this storage, enterprise class storage, off to the operating system and then off to our customers that are running Server 2012. Why not build some new hardware implementations that also can leverage this? And so one of these things that came out that I'm a huge fan of is this concept of a cluster in a box. It literally is a 2 or 4U racked server. Dell even has a standalone one called a Dell Vertex if you wanted to. And it basically has independent nodes that are full-fledged servers. No backplane we're talking about here, like a bridge, like an enclosure with individual blades you plug into. These are actual node servers that have shared power. They can go off and have redundant power. They've got connectivity between the systems for being able to have heartbeats and communication. They've got storage controllers talking to a SAS expander for locally attached disk and also JBOD enclosures on the back end. And basically, that becomes a cluster in a box. Literally, it's a wizard interface you run through once you've given it power, networking connectivity, and then it will go in and basically have a cluster fully set up for you with all these drives attached to it in under 30 minutes, and you're done. Phenomenal solution for office in a box, for branch offices, for retail spaces, for smaller offices, and people even use them as building blocks inside their internal private cloud instead of having to go off and architect everything themselves. So my demo hardware is actually running off of 2 of these. One of them is by data on. This is actually what it looks like. And you can see the 2 nodes on the side. You got 12, you got an enclosure at the front with 12 disks that are attached to a SAS bus. And I've got shared SAS controllers between both those nodes that talk to those 12 drives. Really sweet how that guy works. Now, some investments that we've made with storage spaces kind of rank up and kind of give you an example. A traditional SAN environment, traditional storage, you're going to see basically with Fiber Channel or an iSCSI array that's out there, you're going to get tiering, data deduplication, RAID resiliency groups across the different drives, ability to pool drives together by capability, high availability with clustering, write back cache, copy offload, snapshots, all sorts of different features that you have on there. With 2012 and 2012 R2, we've also gone in and made huge investments. And the biggest thing that we did is we've added tiering in the box for free. Data tiering, massive scalability improvements performance for your IOPS with tiering capabilities. Deduplication, to be able to go through and have VMs that are actually running for VDI infrastructure as an example and have deduplication taking place live on those files unsupported. It is supported, sorry. Flexible resiliency options. We've gone ahead and made it so that we have parallel rebuilds that take place that eliminate the need to have hot spare drives because of the way that we do rebuilds from a performance perspective. Yeah, we pool disks, we have high availability, and we've even brought in this persistent write-back cache in case your drive controllers don't have battery-operated cache modules on them and stuff like that. So all that's in the box, and I'll be talking about that at great length coming up in my session just before lunch on storage and having some really cool demos for how you can set that up, how you can use that now, and use it in 2012 R2. Fantastic stuff that's in there. So the question, is there any noticeable speed difference for running a VM off of a traditional iSCSI target versus the SMB3 fire-breathing Dragon solution that came out with 2012? And the answer is yes, provided you have the networking infrastructure to support it. There's phenomenal difference because you have multi-path to it and you have multiple sessions that are available to it for throughput. It's phenomenal. The best part is, though, as I mentioned, if one node of the scale-up file server goes down that's currently owning that particular VHDX file, the other node assumes those handles and continues going. Your server doesn't even know that node went down. Slight performance download decrease as it basically migrates those handles over, but it keeps on running without dropping a single transaction. Phenomenal setting. So yes, huge benefits over top of running off a traditional iSCSI that's out there at a fraction of the cost. Now I sound like a sales guy. I'm not a sales guy. Trust me on that. You don't want to buy anything from me. Storage tiering is probably the coolest thing that we've got. So you have improved capability and cross performance across all this different types of hardware. What do you need to make this work? A storage enclosure like a JBOD, or even direct attached disk if you wanted to, on a particular machine. You grab all the drives and you create a pool mixing the speeds. You got SSDs and HDDs. It detects that there's a difference between HDD and SSD, and it says, oh, you've got a possible tier here. Do you want to make a storage tier? And you say yes. Once that's done, it goes through and says, okay, how big do you want to make that tier on that individual system? And then you allocate how much is going to be on the hot tier and how much is on the cold tier, where that works. I really have to change my timeout on my laptop. Let's use my corporate laptop for my demos, so it kicks in every once in a while. And basically it goes ahead and it uses solid-state hard drives as your hot tier. Now, just as a word of warning, people always ask me this: can I get different tiers using different spindle speeds of hard drives? And the answer is no. The tiering is only available with enterprise-class SSDs and regular hard drives that are in the system. You get your best dollar per IOPS to speed if you're using 7,200 RPM drives, large capacity drives, and then using fast enterprise-grade SSDs, not the ones you go off and buy from Dick Smith's, the real ones, the expensive ones. Use those ones. I even saw a demo in TechEd Australia from the Fusion IO guys. They had, if you go down to the HP booth here at TechEd New Zealand, they have the Gen 8 servers there, the little tiny small mini servers. They actually put a Fusion IO card inside that little guy, and then they had SSD, and they had that as my SSD drive, as my fast drive in my tier, and they had 4 spindle drives, and they made basically a pool off of that. Phenomenal performance off of that guy, because they're using their technology for how to get that done. Great stuff that's there. Some challenges also came up. How about guest clustering? You mentioned iSCSI Target as one way of doing that. Now picture yourself, not necessarily, potentially. If you want to go off and do guest clustering right now in 2012, you have to have an iSCSI target that you're going to be able to present to that particular VM guest, both of them, to be able to have shared disk, to be able to create a cluster. In a hosting provider environment, you have this environment where basically you have your tenant, your customers, and then your infrastructure down below. You actually have to poke a hole through that barrier with an iSCSI target to be able to make those guests work with that iSCSI target solution, to be able to make that guest cluster, which isn't exactly very secure and well managed for the way that you actually go off and do this for guest clustering. So basically not a great idea to do this. So what we've done is we've actually made a shared VHDX capable system now. And rather than really talk about it, let me show it to you, because I'd rather show you a demo over here. So on my systems over here, I have Scale-Up File Server 1, Scale-Up File Server 2. If I take a look at the details of Scale-Up File Server number 1, you see here that I basically have a bunch of different hard drives that are there on the system. And some neat things here, if you look, this is just a standard remotely accessible VHDX file. In this case, I happen to have a cluster between these two guys that are running, so that's my shared disk that's there. But then under advanced features, right down here, if I zoom in there, if zoom kicks in, come on, there we go. Enable virtual hard disk sharing. With that turned on, that basically will allow 2 machines to have access to the same disk as if it was a shared iSCSI target disk that's on there. So very simply, I can go through here and say, SCSI controller, add a new hard drive. I'm going to browse to my location. I happen to have, they obviously both have to have access to it. Here's my iSCSI 4, my SCSI 4 disk. If I go into Advanced, and then turn on, Enable Virtual Disk Sharing, hit OK, that drive now comes online and is available to node number 1 of Scale Up File Server. Node number 2 over here, if I go ahead and hit Settings, I then go in and add in another disk on this guy, and I choose the same VHDX file. There he is there. Because I have that ticky box turned on, it's going to go in and allow me, turn on the checkbox to enable it, and then hit OK. And then it goes through correctly. That's what you're supposed to do. I did that on purpose. I did. So if I go ahead and take a look at Scale Up File Server number 1, you can now see that I basically have this new 127 gigabyte drive that was just been added, a Scale Out File Server disk between them. And if I take a look here at Failover Cluster Manager, I have both File Server 1 and File Server number 2 up and working as 2 different nodes. And I've got my existing failed server disks already, shared VHDX files already up and running on an individual system. Hypervisor level control, no poking stuff through down to your infrastructure for having IP addresses going on your system. Much simpler to be able to make guest clustering available to more of your workloads inside your environment. There we go, ease of operation, simply to do it, and there it goes. Got about 9 minutes left, and I just want to introduce the concept of software-defined networking. Jeff Alexander's got a great session coming up on networking around the same time I'm doing my storage session. My storage session's cooler, I think, because I'm a storage guy. Don't tell him I said, oh, it's being recorded. He'll find out. Storage-defined networking. Simplified software-defined networking. We remember this whole concept of the cloud in 3 different pieces where you have control down on the bottom end with your private cloud, scale-out capabilities up on the top end with public, and then customization down below on the service providers for the offerings that they happen to have. Well, you're able to basically go through and to migrate your content from any one of these areas back and forth as you need to be able to move your data from one to the other. To be able to do that, wouldn't it be really difficult to basically take an on-prem solution with your hard-coded IP addresses that have been running the exact same way for the last 10 years, and then you don't want to have to re-IP address that particular solution, but you want to run it up in the cloud? If you had to go in and change your IP addresses, it'd be insane. You have the ability to basically go through and have a site-to-site VPN set up with their NVGRE gateway to talk to Azure, as an example, to basically extend the network up into that environment to be able to do some scale. So you can kind of think about it as Team Oracle as the blue, Team New Zealand as the red, and having to have both of the data for the design of those magical hulls of those sailing ships stored on the same server would probably be a very big security issue by the different teams involved. But we can actually have them completely isolated and unknown. They can even have the same IP address infrastructure for those applications on those 2 individual clouds, if you will, running on your site-to-site infrastructure on the same Hyper-V host if you wanted to, and they wouldn't even know. And we're using industry-standard NVGRE solutions as opposed to doing IP address rewriting on the fly. We're doing this through provider addresses and more. And we've also simplified it significantly using System Center Virtual Machine Manager as your fabric control to be able to set this up and to do it. Fantastic stuff. So this gives you basically some network agility to be able to move your workloads around as you need to through your different clouds that's up there. It eases up your management because basically you manage your fabric, both virtual and physical, the same way. We have the ability to go through and to control your top-of-rack switches with PowerShell if it supports OMI, as an example, like the Arista switch. You can do live migration across subnets as opposed to having to be restricted within the same subnet. You could have the virtual guests thinking they're on the same subnet but be in 2 completely different data centers, and they wouldn't even know that they're in 2 different data centers, provided you have the appropriate latency between them. It also eliminates the whole concept of VLANs and having to worry about more than 1,000 VLANs inside your environment because you now simply are managing these different private clouds and have routability and that sort of stuff between them. And then finally, as I mentioned, you can go through and merge your networks onto the same converged fabric if you wanted to. It's that we're with network virtualization. So one of the things that we do is we have with R2, 2012 R2, is an extensible and standards-based solution that delivers this capability using, in this case, we're using a multi-tenant VPN gateway, which is built in to Server 2012 to bridge those different networks. And we're using NVGRE to be able to do the encapsulation. If you look at the packet coming down, basically, if you've ever done packet analysis of how it breaks down on an IPv4 network between host and subnets networks, and then breaking different pieces of those packets down, going down through the OSI level and then back up through on the other side, we adhere to how that works and simply have an extra little piece that fits in there using our hypervisor technology to get there. So phenomenal stuff for software-defined networking. It's built in the box, multi-tenant edge gateway to get you access to those networks. It also basically is self-service capable if you want to go off and to make new clouds and make new capabilities with our System Center solution. And then finally, it's also standards-based. It's out there. For the last couple of minutes, I just want to talk about recovery services. Anyone here using Hyper-V 2012 Hyper-V Replica at all? Only maybe 6 people. The rest of you that are running 2012, I'm assuming you're doing some level of hypervisor with it. Hyper-V Replica is probably one of the coolest features in box after Fire Breathing Dragon SMB3 because it allows you to basically give you a high-end disaster recovery solution in box without any additional cost. The concept of basically going through with 2012 is have your VM on your infrastructure, right mouse click on that VM and say enable replication. You target a destination, you target the security you're going to use between them. They don't even have to be in your same domain. They could be in a service provider if you wanted to. And you can do secure replication between the two of them. It does an initial synchronization across the wire, or you can ship the disk over to your provider. And then once that's done, you can then schedule it to occur on a regular basis. So that VM is always going to be up to date. If ever you have a disastrous issue that go on in your main site, you can then basically go over to the other guy and then synchronize him and bring him up and then fire him up again, and he's all up and working again on the other side. All in box and it's all free. Now, if you're looking at this, it's 2 levels. If you do this with you to your hosting provider as an example, the hosting provider has a backup copy, you're all good. What happens if the hosting provider has a problem? Now you're in trouble. Well, with 2012 R2, we basically made it so you can go 3-way and have a replica to somebody and then a replica from that guy to somebody as well. Hosting providers love this because now they can protect their systems inside their cloud that they're running or provide you with an additional service to do this. You could do this now between your 2 data centers, and then before you'd be stuck, now you can do it between your 2 data centers and the partner data center as well if you wanted to get that extra layer of compatibility. So great stuff there. We even have, with System Center 2012 R2 and with Azure, the ability to have a Hyper-V Replica Manager, HVR solution. So basically, tied in your System Center solution, you can go in and initiate a plan of multiple replications of multiple groups of servers to different destinations. And then when a disastrous event occurs, you can say, hey, do the flip over, go. And no data goes up to Azure, simply the command and control is up there to be able to start and kick off the other guys on the other side. So your data doesn't actually leave your environment. It does the normal replication. Just the control and command goes through that Hyper-V replica experience. Fantastic stuff. And with that, I am just about out of time. So I wanted to leave you with a couple of closing thoughts. Scalability-wise, there shouldn't be any reason why you're not using Hyper-V from a scalability perspective as the best-in-class way of going and virtualizing Exchange, SharePoint, SQL, SAP, other big, massive workloads that you happen to have. It's not your daddy's hypervisor anymore. It's big. It's grown up. It's got the big boy pants on. It's time to rethink storage. Come to the storage sessions. We made a huge, massive investment in storage. And I'll be showing you some really cool stuff you can do with tiering, give you some performance numbers, show you how to set it up yourself on your own hardware to test it out, to try it out. Go ahead and simplify networking inside your environments. There's some good sessions on networking. Go ahead and try to expand your business continuity plans with disaster recovery. Only 6 people raised their hands saying they were using Hyper-V Replica. The rest of you, hey, get started with it today. It's free. It's in box. It's very, very powerful for what you can do. Go ahead and take a look at how you can start to deliver hybrid solutions to your environments that are out there as well. And finally, ensure that your applications are available for the rest of the different solutions and providers that are out there. I have one slide on related content, and I'm assuming you guys have gone through and looked at your session catalog and picked out your bunch of different sessions. There's a wide range of sessions that are out there. A couple that I picked that are really, really good. Ben Armstrong's got one coming up right after this in New Zealand 4 that is talking about understanding how Hyper-V Replica works. I've got one after him in New Zealand 3 for storage spaces, some really cool stuff on storage. Hyper-V, what's new in Windows Server 2012, where he goes down and deep inside the Hyper-V solution and what the differences are on 2012 R2. And then Jeff's got one coming up later today as well on MDC 307, specifically with a wider, I just do storage spaces, he does storage all up. It should have actually been the other way around, but anyway, that's just the way they happen to schedule it for this one here. And with that, I do have an evaluation link for you, a reminder to please fill out your evaluations. It is a matter of pride how people do on evaluation, but more importantly, it's how you feel the content resonated with you, how we can do better to deliver better content to you, and also to be able to do scaling and choices of applications inside this environment here for the next edition of TechEd New Zealand. Now, I do have a giveaway, and for that, you need to be able to stand up and to play a couple of games with me to be able to see if you can get that particular phone as an option. And so, if you're interested, it's a little true or false trivia questions. Ready to play? First question, raise your hand if it's true, keep your hand down if it's false. Windows Server 2012 R2 supports 4 terabytes of memory on the host. True or false? Locked in? Okay. Everyone with your hand up, stand up. You're in the game. Everyone else, sorry, you can't win. Keep standing. Keep standing. True or false? There are no technical differences. Raise your hand if it's true. Put it down if it's false. Standing only, you get to play the game. There are no technical differences between scalability between standard and data center server 2012 and 2012 R2. No technical differences in capabilities for what you can do with server standard and server server data center 2012. True is up in the air, false is down. Everyone with your hand down, have a seat please. The answer is true. There are no technical differences. Only virtualization rights are different. It's cutting the field down. This is awesome. Okay, this one here, you'd have to have already gone ahead and installed and played with Server 2012 to get the answer to this one. Let's see what this one is. Raise your hand if it's true, keep it down if it's false. The default install mechanism for Server 2012 gives you a GUI interface. If you take all the defaults, hands up if it's true, hands down if it's false. You guys all got it right. It is false. The default install is actually a command line known as server core. Going right along, there is a physical limit of 40 simultaneous live migrations. Hand up if it's true, hand down if it's false. Man, you guys are good. Really good. The answer is false. There is no limit to that. Next up, Hyper-V Replica can go to 3 replication hosts. True or false? Everyone with your hand down, please have a seat. The answer is true. There's only 3 replicas you can have with the Hyper-V host. Okay, we're getting down to the finals here. How about this one here? Hand up if it's true, hand down if it's false. You must stop a virtual machine before exporting a virtual machine. Hand up if it's true, hand down if it's false. Man, you guys paid attention. That is awesome. False. You can do a live export. I hope I have enough questions to ask here. I'm going to run out. Hands up if it's true or false. Hands up if it's true or false. Live migration defaults to no acceleration or compression with live migration. True or false? Answer is false. If you have your hand up, please sit down. It defaults to compression by default. Okay, here's one. Hand up if it's true, hand up if it's hand down if it's false. Scale-out file server as a front end supports NFS shares. True or false? Hand down, have a seat. It does support NFS, SMB, and iSCSI. Congratulations. I'm getting scared now because there's far too many people that are still standing. True or false? You can establish a tier between 7,200 RPM and 15,000 RPM drives. True or false? Hands up if it's true, hands down if it's false. Everyone with your hand up, please sit down. It is false. You can only do tiers between SSDs and spindles. And for everyone else that's left, I have to come up with at least another question. You know what? If you're up and then you're left, come on down to the front, right here along the front, if you could. Come on down. For those of you that have to leave because you're out of the winnings, don't worry. I have another phone to give away during the storage session coming up at just around lunchtime over in New Zealand 3 for storage. Thank you very much for coming, and enjoy your sessions. Okay.